Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to hammer through Chapter 2, Section 8. First off, we will look at what is called a compound statement. Compound means more than one. So if we are looking at an equation or an inequality and it is a compound equation or a compound inequality, what we need to realize is that we will be solving two different pieces. When you graph it, you will have two different things to consider. If you have what is called a disjunction, that's where they use the word or. A disjunction, you will be shading away. So you'll have two separated pieces. Okay, let's go ahead and look at the next word. If you have what's called a conjunction uses the word and what happens is you put your two circles, because remember it's a compound statement, so you'll have two solutions on the line. But if it's a conjunction or they use the word and, you'll shade the two together. So the way that I always remember and, I think of times in real life when you use and. Macaroni and cheese, they go together. Mickey Mouse and Minnie Mouse, they go together. Peanut butter and jelly. So when you have a conjunction or the word is and, think of those examples and you know that you just shade together, okay? So disjunction means apart. You'll have two separate pieces going separate ways. Con means together. Conjunctions represent one piece. So they want us to solve the compound inequality, then graph the solution set on a number line. So notice I have two different inequalities. So if I want C by itself, I need to divide both sides by 1/2. So C is greater than or equal to. Remember, you cannot divide fractions. So I keep the top the same, -2. Change divide to multiply. You do the reciprocal of whatever you're dividing by. In this case, it's 1/2. The reciprocal of 1/2 is a 2. So it's C is greater than or equal to -2 times +2 is a -4. Now if I go ahead and I solve for C here, -1, so 2C is less than +1 minus 1 is 0. Divide both sides by 2 and C is less than 0. So again, because it's compound, I have two different solutions. I'm going to go -4, -3, -2, -1, and 0. Filled in circle, open circle on 0, and is a conjunction, and means you shade together. And you're done. Let's look at another one. Or, remember, or is a disjunction. So we will be shading apart. Go ahead and solve for y. So y is less than -4. Here you would -5. So y is greater than or equal to +3 minus 5 is -2. So I solved the two inequalities. Now when I graph them, -4, -3, -2. I have an open circle on -4. I have a filled in circle on -2. The word is or is a disjunction. Dis means you shade apart. Let's look at another one. Hope you guys are having fun. Let's go ahead and solve for x. To get rid of a -5, I add 5. So x is less than -2 plus 5 is 3. Or, so this is a disjunction, I will be shading apart. Go ahead and divide both sides by -3. Negative cancels a negative, 2 cancels a 2, x is alone. Remember, we have that rule. If you ever multiply or divide both sides of an inequality by a negative, we need to flip that sign around. Negative divided by a negative is a positive. 10 divided by 2 is 5. So we go ahead and graph. I have 3, 4, 5. This is an open circle on 3. This is a filled in circle on 5. It is or is a disjunction, which means you shade apart. Let's keep on going. One more like that, and then we get to talk about absolute value. Super cool idea. Okay, to get x by itself, divide by 2. So x is greater than or equal to. Negative 6 divided by 2 is negative 3. There's one solution. And means it's a conjunction, so when I go to graph, I'll be graphing together. To get x by itself, I need to divide both sides by a negative 1. X is all by itself. I divided both sides by a negative, so I need to flip the sign around. Negative 4 divided by negative 1 is a positive 4. Okay, so you go ahead and solve. Get the letter by itself for each inequality. Now to graph it, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. I almost ran out of room. The word is and, so I know I'm shading together. Filled in circle on negative 3. Open circle, that's an open, there we go. Open circle on 4, and so I shade together. So those are compound inequalities. Every problem you would go ahead and solve for each inequality to figure out where the circle would go. Is it an open circle? Is it a filled in circle? Then you look at the key word. If it's and, it's a conjunction, you shade together. If it's or, it's a disjunction, you shade apart. Recall the absolute value symbol. That's the absolute value. It's 2 vertical bars. And what this means is the distance from 0 on a number line. Okay, so if I do the absolute value of 2 and the absolute value of negative 2, what this actually means is on a number line, remember you have 0 in the middle. As you go to the right, your values get positive, or they're positive and they get larger. As you go to the left, your values are negative and they get smaller. Well, if I want the absolute value of 2, what that is actually saying is how many units on a number line is 2 away from 0? Well, it's 2 units away. It's 2 units to the right. Well, if I have a point negative 2 and you do the absolute value, it's saying how many units from 0 is negative 2? Well, it's still 2 units, it's just to the left. So that's why we end up always changing a negative value to a positive, because we're talking about how many units do you travel. Okay, so we're looking at distance. Distance is always a positive value. Let's go ahead and do this. Okay. Absolute value equations, you have to consider that on a number line, you can go to the left and you can go to the right, okay? So what happens here is if I have the absolute value of x equals 3, in order to show that you're going to the right, you drop the bars and don't do anything, okay? So I drop the bars, everything stays the same. But if I'm going to the left, whatever's in the absolute value symbol, you have to go ahead and distribute a negative. So now to solve for x, I'd have to divide by negative 1. So I would have also a negative 3. So this tells me what values on the number line are 3 units away from 0. Well, I can go 3 to the right to get a positive 3, but you know what? I can go 3 to the left and get a negative 3. Okay, so we're going to go ahead and work on this. If you have equations, when you graph, there's no shading. It is just a point. Okay, if you have absolute value inequalities, you have to figure out how are you going to shade. Okay, are you shading together because the word is and, or are you shading apart because the word is or? So here's my little trick. Read the problem the way that it is written. Less than or equal to. So if it's one of these symbols, it is and. Great or great or than or equal to. That's a disjunction, so you're going to be shading apart. So if it's less than, now I'm even saying it wrong. If it's a less than or equal to symbol, be kind of silly and go less than. It's and shade together. If it's greater than or equal to, be kind of silly and read it great or you shade apart. Let's do this. Okie dokie, artichokes. Okay, remember this is less than and you would shade together. This is great or because it's a great or than symbol, so you shade apart. Okay, so if it is equals, you're going to have an equal sign. Okay, this is less than, so you're going to shade together. This is a great or than symbol. Okay, let's go ahead and do this. So here we go. These ones are equal sign. You want to isolate the absolute value bars. That means one side of an equation has to be the absolute value and what is inside. okay? That's what I have here. So in order to indicate that you are going to the right, you drop the bars and do not move anything. But you need to realize that on a number line, I can also go to the left. To go to the left, you have to distribute a negative into whatever was in the bars. Okay, so negative going to the left. What are you going to the left? Negative 3 plus k, your solution stays. Now here are your two equations to solve. To solve for a k, I need to move my minus 3, so I add 3. 10 plus 3 is 13. So there's a solution. Distribute the negative, indicating, hey guys, we're going to the left. This is positive 3 positive 3 minus k equals 10. So I distribute the negative, makes that a positive, makes that a negative. Minus 3 to each side, so negative k equals 10 minus 3 is 7. Divide by a negative 1, and we get negative 7. So if I am graphing this, when you are graphing, you do not have to go by ones. I'm going all the way negative 7 to positive 13, so I'm going to go by 2. So there's 0, negative 2, negative 4, negative 6, negative 8. I have a point at negative 7. 2, 4, 6, 8, 10, 12, 14. I have a point at 13. If it's an equal sign, you do not shade, you just have points at your solutions. So again, we have points at 13 and negative 7. Okay, let's look at the next one. Before you go ahead and distribute the negative to indicate you're going to the left, you have to isolate the absolute value. In order to get the absolute value symbol alone, I need to add 6 to each side. So it's the absolute value of x over 4 equals negative 2 plus 6 is 4. Now that I have an absolute value isolated, it's time to go ahead and separate it into the two equations. I need two equations because I'm traveling to the left and I'm traveling to the right. To show that you're traveling to the right, drop the bars and don't change a thing. To show that you're going to the left, distribute a negative into whatever was inside of the absolute value. So technically, this is a positive. I'm going to the right. But if I bring in a positive 1, it's not going to change anything. That's why we simply get to just drop the bars. Here, I'm distributing a negative. So it's negative x over 4 equals 4. To solve for x, this is x divided by 4. So I go ahead and multiply both sides by 4. 4 times 4 is 16. Here I need to solve for x, so I need to cancel both a negative and the 4. So you multiply both sides by negative 4. Negative cancels a negative, 4 cancels 4, x equals positive 4 divided by negative 4 is negative 16. So my number line, I'm going to go by 5s this time. 0, 5, 10, 15. That would be 20, negative 5, negative 10, negative 15, negative 20. They're equals, so I don't have any shading. I just have points. I have a filled in circle at 16, a filled in circle at negative 16, and we're done. Okay, couple more with equals. Step 1, make sure that your absolute value bars are isolated. That means that's the only thing on that side of the equation. This side is just the absolute value bars and what's inside. To go to the right, drop the bars, don't change anything. To go to the left, distribute a negative into whatever was inside of the inside of the absolute value bars, but leave the 13 the same. Here are the two equations. To get rid of a plus 9, you minus 9. So x equals 13 minus 9 is 4. Distribute the negative. Negative x minus 9 equals 13. Add 9. So negative x equals 22 divided by negative 1, x equals a negative 22. So when I graph it, again, I'm going to go by 5s on this one. 0, 5, negative 5, negative 10, negative 15, negative 20, negative 25. Because it's equals, There's no shading. There's just a point. I need a point at 4. I need a point at negative 22. Done. Okay, the last one, and then we'll go ahead and look at inequalities. I need to isolate the absolute value. This is the absolute value of 6x, so I need to add 8. So it's the absolute value of 6x equals 22 plus 8 is 30. Now that this side is just an absolute value, I can go ahead, step 1, drop the bars. 6x equals 30. Negative outside of the 6x equals 30. Go ahead and solve. 30 divided by 6 is 5. Multiply negative 1 times 6x is negative 6x equals 30. To go ahead and solve for x, divide both sides by a negative 6. Positive 30 divided by negative 6 is negative 5. So I have 0 in the middle, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to the left. It's equals, so it's a filled in circle on 5, a filled in circle on negative 5, and we're done. Let's go ahead and look at inequalities. Now here's where you're going to get my little trick. Step 1, you have to read the problem the way that it is written. The absolute value of negative 4q plus 2 is greater than or equal to 10. Okay, that's step 1. You have to figure out if it's and or if it's an inequality. So at this point, I know when I shade, I'm shading apart. To indicate we're going to the right, drop the bars, don't change anything. To indicate that you're going to the left, negative goes outside of negative 4q plus 2 greater than or equal to 10. Now I go ahead and solve. So if I minus 2, negative 4q is greater than or equal to 10 minus 2 gives me 8. Go ahead and divide both sides by negative 4. This cancels, q is alone. I divided both sides by a negative, so the sign had to flip. Positive divided by a negative is a negative. 8 divided by 4 is 2. Distribute the negative. So it's positive 4q minus 2 is greater than or equal to 10. Go ahead and add 2. So 4q is greater than or equal to 12. Divide both sides by 4. I do not have to flip the symbol because what I divided by was a positive. Here's what I'm graphing. So negative 2, negative 1, 0, 1, 2, 3. Filled in circle on negative 2. Filled in circle on positive 3. The word is or is a disjunction. Disjunction means you shade apart. So it's kind of combining everything together. Let's go ahead and do the next one. Step 1, read the problem the way that it is written right away. So the absolute value of 4x minus 8 is less than. This is an and. It's less than 12. In order to show that we're going to the right, drop the bars and don't change a thing. The way that you show that you're going to the left, a negative has to go into the absolute value bars to show that we're traveling to the left, the negative direction. I have 2 inequalities, I just have to solve them. Add 8. So 4x is less than 20. Divide by 4, x is less than 5. Distribute the negative. Negative 4x plus 8 is less than 12. Minus 8, so negative 4x, positive 12 minus 8 is 4. Go ahead and divide both sides by negative 4. X is by itself. I divided both sides by a negative, so we flip the sign. Positive 4 divided by negative 4 is negative 1. When I go ahead and graph them, remember our beginning, it was less than, so I know I'm going to be shading together. Negative 1, 0, 1, 2, 3, 4, 5. Open circle on 5. Open circle on negative 1. The word is and is a conjunction, so you shade together. Okay, last one, guys. Step 1, Read the problem, silly, so you can figure out if it's an and or an or. The absolute value of 2x plus 7 over 3 is less than or equal to 7. So it's an and. I know without a doubt I'm going to be shading together. Now remember, before you separate inequalities, you have to isolate the absolute value. Right now, this 3 is not inside of the absolute value bars, so I cannot separate it yet. I need to go ahead and multiply both sides by 3. This cancels this, so I'd have the absolute value of 2x plus 7 is less than or equal to 1 times 3 is 3. You need one side to be just the absolute value bars and what's inside. Now I can separate and say, hey, I'm going to the right and I'm going to the left. To go to the right, do not change anything. Keep it the way it is. Going to the left, distribute a negative into whatever was in the absolute value bars. We're going to take that and shift it the other direction. Go ahead and solve for x. So minus 7. 2x is less than or equal to negative 4. Go ahead and divide both sides by 2. Negative 4 divided by 2 is a negative 2. Distribute. Negative 2x minus 7 is less than or equal to 3. If I add 7, negative 2x is less than or equal to 3 plus 7 is 10. Divide both sides by negative 2. Notice what I did here. I'm dividing both sides by a negative. We got to flip that sign around. Positive divided by a negative is a negative. 10 divided by 2 is 5. The word is and, so I know I will be shading together. So I have negative 5, negative 4, negative 3, negative 2, negative 1, 0. Okay, so we just are dealing with the left side of the number line. Filled in circle on negative 2. Filled in circle on negative 5. It is a conjunction, so you shade together. So that, my friends, is section 2.8. Your assignment is to complete the 2.8a worksheet. Hope you guys had a great time today. Talk to you soon.